Hello, hello. Welcome, everyone. Give it a couple minutes for people to start trickling in, but we'll get started. Hey, Michael. Hey, Nick. How's it going?
Hey,
Sam, good to
can
see
you?
you.
Nice to see you. Can you hear me all right?
Well, I can see the room's filling up a bit here, so why don't I get us kicked off? So welcome everybody. Thank you for joining our webinar on Spec-Driven Development in the Age of AI. So I'll just some quick intros on who our panelists will be, and then you let you guys take it away from there. So with me today is Nick DiFiore and Michael Montanaro. You guys might remember Nick from our prompting webinar a couple months back. But Nick is, I think he was employee number 4 here at Blitzy. He's done just about every job, even from hand compiling right at the beginning to now running some of our largest client engagements. So Nick is really the go-to person on how Blitzy works. Same kind of thing with Michael. He is our first forward deployed engineer, and besides our CTO Sid, he's the person who knows how to use Blitzy the best. So you guys are in great hands. And Nick, I'll pass it off to you.
Yeah, sounds good. Well, thanks, Sam. I know Michael and I are fired up to start this conversation. We've been nerding out about this over the past few days, trying to narrow down exactly what we want to talk about because there's so much here. But I think when it comes to spectrum development, kind of where we landed, that I think would be most interesting for folks is to talk about really the past, the present, and the future of the spec as it relates to software development, and kind of cover it chronologically. And start with the history, talk about where things are today, and then where we envision and where really the industry envisions the spec moving forward. So I'm going to share some slides as we walk through, but maybe I'll pass it off to you, Michael, to start out and just talk about where the spec began with respect to software development. I know we've got a few kind of stories and historical events that are really key here that we think would be interesting for folks to hear about.
Yeah, thank you for the intro, Sam and Nick. The problem of software was first defined in around 1968 in Germany in the NATO conference. There was about 50 scientists that came together to have a discussion about what they were deeming as a crisis. Software was failing, not because of bad machines, that was actually quite ahead of its time, but because projects were getting too big to fit into an engineer's head, even a team of engineers' heads. That night was the birth of the term software engineering. And the idea of building software should be as disciplined as building bridges. And because of that, we have started to develop these techniques that we're going to dive into a bit more today. But it's very crazy to see that 50, 60 years ago, the problem was defined, and we're still looking for ways until today to solve that.
Right. Yeah. And I think what's really interesting to dig a little deeper is like, what was that problem defined as, right? And I think the thing we were talking about earlier is the largest problem was about scaling, right? So um, as you think about writing software, the more software there is and the more you can write, and this is something that obviously is more relevant with the age of AI as well, but like the bigger the problem becomes, right? And so at this conference in 1968, the question was really about like, how do we write software at scale, and how do we address the fact that people are going to be writing a ton of code, and there's not going to be guardrails around it, right? And I think this is incredibly relevant to the enterprise. And back then, it was incredibly relevant to the enterprise, right? Like you have these NATO leaders getting together, talking about governments and large corporations that are going to be writing massive amounts of code. Like, how do we make sure that as they scale, there are guardrails that are around, how people are writing code? And so, again, it's really relevant to the enterprise specifically because they're the ones who are going to be writing the most code. And so there need to be those enterprise specific standards. And that's really what that conversation was about. And I think what's interesting here to kind of maybe transition to another, I think, interesting historical story that you have is that sometimes or oftentimes without the presence of a spec, teams can kind of bite off more than they can chew, right? I think is what we talked about in terms of writing code, and the actual implementation of what's developed can be different from what the intention was, right, Michael?
Yeah, you hit it right on the head there. So there's a very famous quote that spawned about 4 years after that NATO conference from Dijkstra. The quote is, "When there are small machines, programming was a small problem. With gigantic machines, programming became a gigantic problem." Now, the machines that he's talking about here are machines that run about 2 million instructions per second. The Bluetooth chip on your phone today is around 80 million per second. So I think he'd probably be a bit stressed out about how complex software has had to become, just to keep up with the hardware changes here. And a good example of one where the software was lagging behind, we kind of engineers bit off more than you could chew, as you said, Nick, was in the Denver International Airport. I don't know if anyone has heard this story before, but around 1995, there was $560 million automated baggage system that was scrapped. It was 16 miles of track, and it was beautifully developed on the hardware end. Everything worked perfectly. There were sensors, and it was really a marvel of engineering. Except the system had a bit of drift in terms of what it was defined to do and what it actually did. It didn't have catches in the system for any errors. Maybe there was dust on the sensor. Maybe the bag was placed a bit misaligned. And what ended up happening was a log jam. These bags would get dropped in the middle of the room. No machine would sense that, and it would just keep compiling, keep building up this mistake, even getting to the point where bags were being shredded. So that's all to say that engineers with growing technology, they have aspirations, and it can be difficult to scale those aspirations with your team.
Right. And I think to kind of tie this back to, where we're talking about the spec, right? Like, how is this relevant to the spec, and why is this a part of our conversation, right? So I think the interesting note here, the summary is that you talked about is the difference between, or the drift between, like desired implementation and what actually gets implemented, right? And that's what these conversations with NATO and like the Denver airport example, I think, allude to, right? Is that in the absence of a source of truth, the actual engineering implementation that gets put into production can actually be far from what the team actually wants implemented, right? And I think engineering leaders will probably appreciate this today, right? Like you have a meeting that's scoping out a new feature or a modernization effort that you want. And in the absence of a source of truth, like a document or, for example, a spec, that would likely not get implemented, right? There would be a ton of drift from that initial conversation. And so, Michael, I think it would be interesting to talk about like the progression of how people took that problem of drift and started to implement solutions, right? I know it started with just using like mathematical testing as a source of truth, and then moving to like mermaid diagrams and the like. Could you walk us through, I guess, that series of solutions that historically led, I guess, to the spec?
Yeah, most definitely. So, as software engineering began, the first issue that needed to be solved was being able to prove at scale the software does what it was said that it was going to do. And the easiest way we could do that at the start was applying mathematical formulas to it, because we knew exactly how to prove those. Now, that does not scale with humans at all, and we've already come across that problem. So what did we end up switching? What did we end up having to navigate to? And that was what we've gotten today, where UML diagrams, I use them on a daily basis. I read them on a daily basis. They're incredibly useful. The issue is the moment they're written, they're stale, and they usually take quite a while to write. But the goal of it was to create a unified language to describe architectures, to describe systems as they continue to grow into the hardware that has now been made available to them. But as I said, the moment that's written, it is stale. So that can even bring more problems. You have engineers reading code that is no longer aligned with what the actual implementation is, and thus we have drift yet again. We're going to be hearing that word quite a bit.
Yep. Yeah, and just kind of transitioning now, once teams went from those UML diagrams, the next step in that process was the spec, right? And so we see in the early 2000s was really when spec-driven development, this idea was initially brought to pass. And so that was kind of you know, the first time when people were using these large documents, to drive the code generation. And the idea is that this is supposed to limit drift in software development, right? You have your source of truth in a spec, and your engineers are working off of that and implementing based off of that. And so that's supposed to minimize the drift. But like you talked about, Michael, like that spec can often become stale, right? So that's the issue that people saw with spec-driven development, I think, in the early 2000s. Is that right?
Yeah, and it ended up getting a very bad name from a quite a public failure. So just to define it a bit more, we got spec-driven development, specifically behavior-driven development, specs that are in plain English. CEOs can read it, engineers can test against it. It's the language that we use today, that we use to solve the problem today, but the spec was still just a suggestion. It wasn't exactly the state of the application today, and it certainly was not the future state of the application. It was interpreted by the developer, and that interpretation was the output based on how the developer found that spec to be. Now, what was the failure that ended up leading to a surge of agile development taking over engineering teams? The FBI actually spent $170 million on a modernization attempt. It ended up with 600 pages of a requirements document. So before a single line of code was written, they spent 2 to 3 years writing this document, making sure that each aspect of their system was planned and mapped to the target state. The issue was the moment that it was written, it was no longer viable. It was dead on arrival, if you will. The build was too big for this system, and we could not spec it out at the speed that was needed for that scale. It was too rigid to survive contact with reality. We had new versions that came in, and new dependencies, new business requirements, dynamically filling this document that was already behind. So it was scrapped, 170 million, no lines of code, no modernization, which led us to agile development, which is taken over the 2010s. Now, I'm a fan of agile development, as most engineering teams are. You can ship quick. You don't need to spend most of your days writing long specs. They've given way to short tickets, short descriptions. Individual contributors can grab their tickets, make the kind of block-based updates, and that audit trail is the smaller tickets as they go in.
Mm-hmm.
The issue is that's a very, very large risk of the drift that we had talked about before. Now, before we had the specs being the source of truth, and we were trying to keep that in line with source code. In agile development, we basically give up the spec, and we're saying the source code is now our source of truth. And we're going to know that, and that is going to be how we continue to grow our application. Onboarding gets longer, and the amount of bug fixes that need to happen after the changes go in also grow.
Right. Yeah. And I think to jump in here, Michael, like what I think the summary is of what we're seeing here in these two, I guess, phases of software development is like there are trade-offs with each of them, right? So you talk about agile software development. There's the ability to ship significantly faster, but the absence of a continuously updated spec, there are trade-offs that are associated with that, right? You talked about potential drift, right? Because you don't have that like detailed description of what is to be implemented. You talk about like longer onboarding times, right? I hear from a lot of clients when we first start working with them, like the code is the documentation or the code is the spec. So a lot of teams that I work with don't even have these spec documents. And so that's kind of the summary here, right? There's trade-offs for agile development. Obviously, teams love it, you love it, but there are trade-offs associated with it. And I think what's really interesting to talk about is this future of software development, right? Um, how does spec-driven development essentially um, play into how development teams work moving forward, right? Do you want to talk a little bit about, I guess, broad strokes, what this looks like?
Yeah, I'd love to. This slide, I think it represents perfectly how every attempt that engineers, software engineers have made to bridge that initial 1968 gap, that problem that was defined that ended up coining software engineering. Every attempt has gotten us closer, but we have been unable to eliminate that gap, the bridge between spec and source code. Now, there are industries that are doing it. So before we dive into the coding portion of it, of spec-driven development, I do want to talk about a use case that's happening in the real world today. Automotive engineers have been doing this. This is how they develop. In Simulink, for example, you build an engine control algorithm as a model. Once you verify it through simulation, basically proving that it's correct at the design level, then a certified generator produces the C code. The engineers never have to manually edit that code. They're
Mhm.
responsible only for the model. It's the trust, the confidence they have in that model leads to the complete miss, I guess, if you will, or completely skipping over being able to read, edit, or read the C source code. There's just no need. It would frankly be a waste of time in that industry. The machine handles the translation, so there's no need to check over its work once that trust has been built. It's a very formal proof. And now, for many years, we haven't had this sort of proof in software engineering, and we're still working our way towards that definitive proof. But the principle of spec not being a documentation, but actually being the source is the key here. And I really wanted to double down on that. So what do I mean by the spec is the source? Well, rather than interacting with the code and having to read through files that have been written 3 years ago, maybe by engineers that are no longer at the company, you are reading the source of truth from a human readable English language spec, usually 600 to 700 pages. We can look at one later today that's close to 1,000 for around a 40 million line code base. But you can see that there's no real need to dive into the code if you have the trust and confidence in the spec. And then there's that bridge of we have the current state spec. I keep referring to it as a spec, but we're going to talk about that as this large document that gets generated with an understanding of your code base from a very deep level. But how to bridge that gap to the target state is where Blitzy's specific implementation comes in, where the agent action plan forms the bridge between the current state tech spec and the target state tech spec to describe exactly the changes that need to be made to end up at the state that you would like.
Right. Yeah. And I think that's a really good segue. We've talked about, I guess, the history, the current, and now looking at the future of software development and how the spec fits into AI or software development today. And really, I think the interesting point here is why is spec-driven development in the age of AI different than spec-driven development was in the early 2000s, right? And so the best way I think to talk about this, Michael, is about how Blitzy uses specs and how people can benefit from this documentation process or documentation framework that the Blitzy platform allows to take advantage of the spec, but also not allow it to become stale, right? So when we talk about specs in Blitzy, there's really two different documents that we talk about. And folks on the call who are clients of Blitzy will be familiar with these specific documents and these terms. And I think walking through these at a high level would be helpful. So again, when we talk about specs with Blitzy, there's really two different documents we're talking about. There's the tech spec document. So this is a document that is describing the current state of your code, right? You can see here it's autonomously generated, but really importantly, it is continuously updated, right? So when you onboard a code base onto the Blitzy platform, for example, you get this tech spec document that's generated. It is generated after a few days of autonomous compute. You can onboard a code base of any size. The one we'll show today is for a 40 million line code base. And the document can be, somewhere from a few hundred to up to 1,000 lines or pages. So it's a huge document that is, covering your code base at a high level and where it stands today. And again, the key thing here is that this is living and it gets updated every time new code is committed to your code base. So think of this as a snapshot in time of your code that changes and updates as you go along, right? So Michael, you talked about tech specs or specs getting stale being a real challenge for folks as they initially did spec-driven development. The fact that this is now a living and breathing document that continuously updates basically gets rid of that issue of the spec becoming stale and allows you to always have a honest and up-to-date source of truth. Anything to add there, Michael, about the tech spec?
Yeah, the tech spec for me as a engineer who really enjoys open source has turned legacy systems, legacy languages, dead languages that used to be a black box or that might have just been, frankly, a waste of time to learn or to onboard onto, makes it clear, makes it something that you can read as you're on a train trying to just grow your knowledge as a software developer. We spend a lot of time for Blitzy projects in that ingestion phase and making sure that engineers who are getting used to getting comfortable with the platform, they read through that document and they can actually know their code base better than they had beforehand. So just to dive a little bit into how that process works, it's called reverse spec-driven development. So you take the cluster, the bird's nest, if you will, that is a legacy code base or a code base that has just been in existence for a while, many million lines. You have a number of engineers, each with their own understanding of bits and pieces, and that network builds your company's understanding. That's frightening. If you have any individuals leave, you have bits and pieces that are muddled in gray, and you no longer know what might be going on in there as deeply as you did previously. And the worst part is you don't even know what you don't know. So the ingestion process builds a very deep understanding. It's almost like you sent a bunch of your top engineers to go through and map exactly what each section of the code, each line of the code is there for, checking it against commits, checking against comments, dependencies, third-party dependencies as well. Just building out this understanding beyond what is comprehensible by humans, frankly. And that is just part one. Then you have the ingestion prompt, which lets you swing and sway the wording that Blitzy uses to describe its understanding to you, rather than just having a typical spec that you can't really modify based on what your expertise is or what you really care about. Blitzy goes a bit further and it leverages this knowledge graph, which is what we define this code ingestion process, and it writes it to the engineer, but it can also write it to a specific section of the code that the engineer wants to dive more deeply into. So it creates this almost conversational understanding of code that previously had not been able to be achieved.
Yeah. Yeah. And I think the interesting discussion or point here is like, how is this valuable or how is this leveraged in the scope of team software development life cycles? Because a 1,000-page document about the code base can be daunting for some folks, but talking about like why is this important and why is this valuable, I think is a good conversation to have too. So this quote down at the bottom, I think is really, really important of, you can't basically build on top of the house without knowing the floor plan, right? So this tech spec operates as a current understanding of Blitzy for the code base. And it also operates and allows your engineers to know exactly what the current state is, right? And that's really important as you're going through scoping discussions and prioritization, right? How can you make a decision about like what new features need to be implemented or what modernization initiatives you're going to prioritize as a technology organization without knowing the current state of the code base? And some of the folks on here may think that their code base is in a spot where the team understands it quite well, and that may be the case for some people. But just anecdotally, my experience in the field has been that when these tech specs get generated, people are really amazed at what they're able to learn or what they have learned by reading through it. And Blitzy is taking a fine tooth comb through this code base, reading through every individual file and developing like a complex mapping diagram of all the dependencies. Um, Engineers at the organizations I work with really haven't gone into that level of detail a lot of the time. And so this tech spec uncovers a lot of insights about the current state of the code that folks actually find really valuable when they're going through scoping discussions and like prioritizing features and modernization initiatives.
To add to that, Nick, if the tech spec is your institution's knowledge that your best engineers would carry, made permanent, or at least made in a way that can update as the code base continues to grow, then the agent action plan becomes the bridge between technical
Mhm.
implementation and the target state application. So that's, I guess, where the bread and butter is, if you will, of this Blitzy process. You can be certain that the plan that Blitzy puts into place aligns with what is feasibly possible in the tech spec. So engineering teams often will even put in prompts just to see what the agent action plan will be based on their code base, because it's almost like you have a team of architects looking at that knowledge graph, looking at the tech spec, and planning out how your code will grow before you've written a single line. So the agent action plan is really that bridge between current and target state.
Yeah, it's a great point. I think a good transition because, like you mentioned, this is really like the bread and butter of the call it spec-driven development process in the age of AI. Um, and to, I guess, zoom out or take a step back, the agent action plan, the way this gets generated, right? So the Blitzy process, how this works is you ingest your code base, you get back a tech spec, and then you give a task to Blitzy via a prompt. So for example, this could be a new feature addition, it could be a language migration, a modernization initiative, whatever is top priority for your engineering team. You write a prompt, submit it to Blitzy, and Blitzy gives you back this agent action plan, which essentially tells you, Blitzy's understanding of what is going or its plan to implement whatever you specified in the prompt, right? So, like you talked about, Michael, this is a bridge between the current state and the future state. And you can essentially feel confident that you understand exactly what Blitzy is going to go off and do because it's telling you back kind of its understanding of what it is planning to implement. So, Michael, anything to add there about the agent action plan?
I do. We may need to push back the Linux demo a bit more if we want to stay on this slide. I would love to talk about how rules comes into play here to help align with
Yeah,
compliance, and how we've the spec-driven development. It was a way uh, to track how the code base continues to grow and to make sure that the understanding within the company of what the code is actually doing is in line. There's no drift between what the perceived functionality is and what the actual functionality is. Now, that can be very difficult. We got a fantastic question before this webinar about bitemporal issues, right? So let's say, for example, you have a code base that has a couple data points, one being subscription started and one being subscription created. Now, in terms of compliance, that would be very important. It would be very crucial to maintain both of those entries. So as the agent action plan is going through and making the plan, it can ensure that the spec is compliant with that rule, with that business requirement, which is just a code snippet that your company would apply to all projects moving forward. Now, what would happen if this is not the case? The request would be something along the lines of create or update this schema, and the application would see that, hey, I need to put in a field here. Let's say I need to put in a date field here. It knows that the created at date was there, and rather than building a system that keeps them both in parallel and line with each other, it would override it. Now, that's completely functional code, and it's code that frankly a junior developer would write and not think two seconds about. But that's a very expensive miss. It would breaks compliance, and I remember reading around $30 million in terms of what that would cost an organization if this compliance were not met. So the agent action plan is not only a way of making sure that the way you'd like to grow the application is technically compliant with how it could grow, but you can also bake in those business requirements or any of the external requirements into the planning process, so that you're basically adding guardrails and you're shaping the way that your application will grow and the way that the agents are viewing this growth.
Right. Yeah. So you mentioned rules as a mechanism to implement this. Can you tell me a little bit about kind of how that fits into this framework and maybe the process? I know we have the tech spec as the current state and then the agent action plan as the aspirational state. How does a team bake in some of those regulatory requirements or even just enterprise specific preferences to make sure that they're captured in this spec?
Yeah, so I'm gonna step back from technical to describe rules and talk about one of my favorite ones, and I add it to every single run that I do. It's called the executive presentation run. That is in line with this run that we've coined as explainability. And basically, what the two of them do in tandem is an agent will go through, and anytime there's a non-trivial decision that needs to be made that might require some just some explanation, it gets put into a decision log. So as you're going through and you're reading larger PRs and you're trying to figure out what those changes may have been, then you can go and you can read the thoughts just as you would go to the engineer's desk and ask him, hey, why did you do it this way? Why did you make these types of decisions? Now, the second part of that, the executive presentation, is the one where oftentimes after we finish finish tickets and especially finish the quantums of work that we're doing here in terms of tens of 20s, thousands lines of code, we create a presentation rather than a markdown document, or rather than having to spend time to build up an explanation of what the code is and why it's going in. You have Blitzy and the Blitzy agents do that. They already have the left side of the screen there. They already have the tech spec information, the institutional knowledge that is your code base, and they have the target state, the agent action plan. So they're able to use both of those as well as its actual implementation once it completed to give a perfect summary of what has been done, why has it been done, and you can just swap that based on the audience that you would like to present it to. So if you're presenting it to your engineering manager, that's going to be a very specific presentation, and you want to make sure that the QA engineers that are also going to be reviewing these documents, they are able to map that back as well. So we're really creating this breadcrumbing trail almost of documents, not only for agents to help guide their development, but for human developers and for the various stages of engineering that are required.
Mm-hmm. Right. Yeah. And we talk about stages of engineering. I think the agent action plan from the teams that I've worked with has been really helpful for them as we talk about the scale of development that Blitzy is capable of, right? So when you are, for example, let's talk about, independent of a platform like Blitzy, um, working on larger projects or larger scoped initiatives, it's really important to have, like we talk about, a spec that details what the team is actually supposed to do, right? So if you, Michael, had a team of 20 engineers who were going to perform this massive modernization effort, you would want to make sure that they have an understanding of what they are supposed to do and a really high fidelity understanding of that before you have them, go off and do that type of work. And so, think of Blitzy in this case doing the work of that 20 engineer team. You are giving Blitzy instruction, and it actually tells back to you in this agent action plan its understanding of the task that you've asked it to do, right? So it's really a valuable kind of checkpoint for teams before they have Blitzy go off and perform these autonomous projects or initiatives, because it allows for teams to feel confident that they know what Blitzy is actually going to proceed with, and what its plan is for generating the code.
And it's really become the highest leverage gate for humans within this AI native software development. You have tools like Claude Code and other co-piloting tools that create one-off plans, and that really does drive for better generation on those smaller individual contributor type tasks. But the fidelity between AAP and the generated code within the Blitzy platform is extremely high. So Blitzy is not going to improvise beyond the plan. It's going to execute exactly what the AAP says. So it really pays dividends. Minutes editing the agent action plan before you click code generation can save your team hours, days, even weeks, depending on how large of the run is. And that's a scale that we have not. It's hard to grasp, really. There's been a shift over to a form of spec-driven development in vibe coding. But this two-pronged approach, the ingestion aspect of it, the living document of the tech spec, and then the bridge that is the agent action plan, and drives the Blitzy process. And as I mentioned, the vibe coding portion of it, and it's really, I'd say it gives me more confidence as an engineer seeing these large documents and knowing that if I read through this and I validate it, then the assumptions that were caked into the words into my request are going to be flushed out. So I can actually read the assumptions that the Blitzy agents made based on my code, versus in the planning phase of co-piloting tools and tools that don't have this context that we are dealing with, that we're building using the tech spec. Those are just guesses, right? We're taking words of an engineer and we're trying to figure out how to fill in the gaps of what was not said. And sometimes that is aligned with what the architecture requires. Sometimes it's not. And as an engineer working at scale, working within an enterprise, those are not risks that we can really take at all. So in order to be able to tell the difference between what your request is and what needs to be done, this agent action plan is the middle ground that kind of eases the tension or the stress a little bit of the speed of software development with AI.
Mm-hmm. Right. And I want to transition now to quick discussion about why this matters, and then Sam, I know we've got a few questions already, and want to save time for Q&A. I love this point here, just in the middle, that documentation used to go stale and now it doesn't. And I think returning back to that conversation of the history of spec-driven development, right, in the early 2000s, and that story about the FBI that you shared, Michael, like that was the real challenge with spec-driven development, and why it was ultimately like moved away from, and why teams moved to agile development, is that these specs became incredibly stale, and the ability to continuously update them is incredibly helpful for engineers to have that constant and updated source of truth, right? So that's really what the difference is between agile, or excuse me, spec-driven development of the past and spec-driven development of today is that that documentation no longer goes stale. And so, Michael, I think it's interesting to talk a little bit about like why up-to-date documentation is helpful for teams, right? I know there's a few things we had talked about previously of like enabling individual contributors to be more efficient with Copilot tools, and then also, enabling engineers to be onboarded quicker. Like, what is the benefit of having that updated documentation for engineers?
Well, if you think about what the requirement was previously for spec-driven development, rather than it being an IC enabler, it was a serious hindrance. You would have to take so much time, either usually both at the beginning and at the end of generating those tickets, of implementing those functionality throughout the application, that it grinds development to a halt. Now, given that it's a live document and engineers are no longer having to use engineering hours to develop these specs, to develop these plans, it becomes an enabler. It allows an
Mhm.
engineer to skip over the wiring, the boilerplates, just hours spent reading other people's code. Again, as I mentioned before, sometimes that can be quite challenging if you're in an organization that has quite a lot of churn, if you will, where you're not able to track down the code owners or feature owners. So it becomes an enabler because it gives a lot more autonomy back to a developer. It almost makes them immediately into an architect uh, over a code base that could far exceed their lifespan. It could be a code base that's been around for 40, 50 years, and suddenly you put in a request and you get an agent action plan that is as in line and as accurate to what the architecture needs as an engineer that has been working there for the entire lifespan of the application. And
Mhm.
you also had mentioned the onboarding accelerator. I kind of talked about that a little bit there, but rather than just allowing you to contribute faster, it also lets you be able to converse about the application and know what's going on under the hood, what's happening in the areas that you have yet to touch or that you may never need to touch. Those aren't necessarily drivers of your individual development, but it drives your holistic understanding of an application, which in turn drives your role as a developer to be that much more impactful.
Right. Yeah. And I think another point, Sam, before we dive into questions, is about how these specs actually impact um, AI code generation tools, right? Not just Blitzy, but your Copilot tools. Um, and again, I think this addresses one of the questions I saw in the chat about having these documents checked into the repository and what that actually means for these tools that are now able to reference the specs. Michael, do you have any comments on, I guess, how we've seen Copilot tools performance improve once these specs are generated and then checked into the repo?
Yes, I love this question. So I have a lot of non-technical friends who are attempting to get more into software development as well, and I've have had them leverage this technique quite a bit. The technical specification that gets generated is not just your holistic understanding of the architecture at hand, but it also gives your Copilot tools this 10,000-foot view that they had never seen before. So rather than you having a very hyper focused assistant at your side who is really digging into the file or the feature that you're implementing here, with the tech spec that's sitting just within your code base, even just as a markdown file, the standard operations that go through Copilot tools in terms of searching for similar words and just trying to gather context, it's now gathering this high level understanding of the application that will then drive the decisions that it makes in its smaller term planning process to be significantly more accurate. So you're almost building out an IC version of the agent action plan using that tech spec.
Right. Sam, I see you came on camera. Does that mean we transition now?
Yeah, I think so. I think that's a really good segue. I mean, Nick, you took the words out of my mouth with that answer. But one of the questions from the chat, which we've touched bits and pieces of it, but I kind of want to dive a little bit deeper on it. So the question is, in spec-driven development with AI, there's a large amount of documentation that is generated. So you did mention that these documents will be checked in along
Hmm.
with the code, but if it's a monorepo of an existing large project, can the AI reconstruct the specs for existing features, which we know Blitzy is yes. But then if the answer is yes to both of these questions, then why should we retain the previous spec documents?
So the technical specification does not live within your code base. The agent action plan will get checked in with each PR. So there are two artifacts that will get checked in. There's a project guide, which is the an explanation or a summary of the work that has been done, and then the agent action plan, the contract that was driving that code implementation. You can think of it as the intent is written down in the agent action plan. The agents test against it and enforce it before the code ever enters your version control system. So before the PR is ever made, the agent action plan is that source of truth that's getting validated and checked against. However, the tech spec, which is the living document, the current state of your code base, that lives alongside it. We maintain it on our platform. It can be downloaded at any time. But we have two views: a knowledge base, which is basically a library of your company's, your organization's technical specifications. So that way, you're not having to maintain or figure out if you'd like to keep the different versions of the tech spec. They're getting updated and overwritten in time.
That's great. And then I think another question that was in there that kind of is related to this is, can you explain how specs are reviewed for cross-functional correctness by product owner, architect, developer in QE?
I'd be happy to. So we do have a great video on this, thanks to one of our technical content creators, Amanda. It's on the docs.blitzy.com. I don't have the full URL in my head, but it's within the docs.blitzy domain under technical specification. But we basically go through what we call spot checking. So you would pull together a team of technical analysts, if you will, and you'd point them to the different sections of the spec that they would then need to validate. And oftentimes, what we'll see is it starts a discussion. So we recommend bringing in one or two from each section, from each sector of the engineering. Let's focus on security. We had two security engineers review the technical specification, and then they can really start a discussion to what they're seeing. Most of the times, there's going to actually be an understanding or a misunderstanding that gets resolved from one or both of those engineers from the document. But by breaking it up in that way, you can have those smaller conversations and really dive into where the tech spec aligns with the code. After you do that for the first pass through, after you do it for the first ingestion, there's no real need to keep validating it as it grows. You've essentially turned the source code into the compiled version of the source spec, if you will. So once that confidence grows, you're now working as an engineer against the spec.
Great. Thank you for that explanation, Michael. I think probably time for one more question, this last one. So this is from someone who's primarily focused on data in a system and wants to know what the typical scope of a customer engagement is like. Do the agents make changes to the data layer, or is it just software upgrades? And if they do make changes to the data layer, do they do any upgrades or anything to change the procedures that populate the data layer?
So I'm trying to find this question in the
Yeah,
Q&A.
me too. Let's see. Yeah, so I think, Michael, this is largely about where in the code base, or I guess, what is the scope of changes Blitzy works on. Is it limited to software, and how is it related to data? Um, I think I'll take a first pass, and Michael, add details here. But Blitzy largely works at the software layer, right? So it is a software development tool, where it interacts with the data. Is that it can write things like scripts, or code to interact with the data layer, but it's not actually interacting with the data itself, right? So a database migration or something like that would not necessarily be in scope.
Yes, and that is what we'd recommend in terms of best practices for using AI native development tools in general. However, Blitzy does have something called an environment setup file, which allows you to describe the process that the application would take to connect to various dependencies. And you can, in fact, give it access to a staging database. You could give it access to the production database as well. We do not recommend that, but Blitzy will take the software development lifecycle, or more specifically, the product development lifecycle, as far as you are willing to take it. Even being able to connect to staging cloud deployments, pushing and reviewing logs based on how that deployment went. I did want to. I know we had one more question. I did want to talk about why specifically I mentioned PDLC there, and it's one of the keys to the agent action plan. So we can take documents like Figma, which is used to drive development specifically in agile development. You a lot of times you'd have a backend engineer looking at a Figma deck, and they'd see exactly what content or what data would need to be brought from the backend to propagate into the front end, and the front end would do the same, and they would see exactly what they would need to make the page to look like. But that is interpreting a Figma document that was generated by a designer, that was created by a designer. And what then that designer has to do is he has to go back and make sure that the backend engineer interpret it correctly and the front end engineer interpret it correctly, and it's staying in line with that Figma. Otherwise, we have, again, that drift. So how does Blitzy and the Agent Action Plan fight this? You put the Figma as part of the prompt. And then the agent action plan pulls all the tokens related to those designs. So it would pull any of the styling, pull the padding, and then you can visualize exactly what is going to be changed visually in the agent action plan, seeing all the styling behind it, any assets that may need to be downloaded. So it's addressing the drift at a visual layer, not just at the software layer.
Awesome. And I think this last one just ties nicely into that, I think, Michael. So going to your historical software engineering background, specs in the past were very large documents. Agile software development dealt with stores which could be almost arbitrarily small, and epics which are larger. So if there's a continuum, large doc specs to stories, what size of spec should we be solving problems at?
What size would specs be solving problems at?
Yeah, so I think this is a great question of largely like what is the scope of problem we should be executing at in the scope of, I guess, a Blitzy project, right? So previously a spec was massive. Now it's a user story that could be something that takes someone an hour to implement. And so in this new age of AI native spec driven development, what is the scope of problem that we should be solving at?
So this is a great question. Thank you for kind of explaining it to me a bit more there, Nick. It's one where it's dependent on the engineering team, dependent on how they would like to go about the review process and integrating it into their system. It is one where we can build out and define very large scoped changes, and there are times when that is very much essential. Think large scale modernizations, language upgrades, where you're taking the application in its current state and you're completely upgrading or migrating it to another system, almost a one-to-one switch. When it comes to feature additions, bug fixes, maybe it's security audits or just general audits. Those are situations where you may want to piece them out and make them a bit smaller, and that's a fun concept that we like to call user stories. So Blitzy actually will take its understanding using that knowledge graph and build out a detailed, almost book of a set of epics, a set of larger plans, initiatives that it will end up getting to in the application. That would then allow your team to read these documents, which are just markdown documents that would be checked into your code base, and use them, edit them, and point Blitzy runs to the different sections that you'd like to be implemented. So you're still leveraging that knowledge base to build out large scale changes and still drive that efficiency, but you're chunking it in a way that lets your team handle it in a bit more of an agile manner.
Hmm. Yeah, and I think the one takeaway here, John, to your question is that uh, there's no limitation at this point, right? The only limitation is really in terms of uh, being able to review the output and validate the output, right? So Blitzy can operate for days or weeks at a time. And so there's no longer kind of a limitation in the scale and scope of what we want it to do. But the key is picking something that can be easily validated, right? And so we take a lot of steps with teams initially to build out test suites that allow for easier validation when the code actually gets generated. And so that's kind of a important component of it. But the limitation is really only related to what you can validate.
Awesome. Thank you both so much. And thanks to everybody for joining this. This was really good. I learned a lot personally, and I'm not an engineer. So I just put Nick and Michael's emails into the chat in case anyone has any other questions that did not go answered. As well as I just want to say, with a free account on Blitzy, you can ingest up to 100,000 lines of code and actually create one of these technical specifications. So even if you don't have an enterprise plan, you can generate a tech spec for your project and then use it to help you start building with a copilot tool like a Claude Code or a Cursor. And the last thing, just a quick shout out. Our CTO, Sid Pardeshi, is joining a webinar with Anthropic on Wednesday at 11 a.m. Eastern time to talk about our better together story and how Blitzy uses Opus 4.7 to build off of that Opus 4.7, but then we also use the other frontier models. So that'll be a very interesting join to anyone who is interested. And I will pop that link into the chat right now as well. So thanks again, everybody, and I hope you all have a great rest of your day. Thanks, Nick. Thanks, Michael.
Thank you all.
Thanks, Sam. Thanks,
Thanks
everyone.
for
Bye.
joining.